Welcome. So in today's section, I just wanted to give my thoughts of the current AI landscape, go through all the details at pretty high levels, just so you can understand where the industry is, maybe the current problems each sector is kind of facing, or part of the AI problem, I should say, and what are the issues. So we're going to look at infrastructure, frameworks, we're going to look at RAG, vector database, a bit of chunking, agents, and agent orchestration, and some agentic workflows tied into that at the end. But to start off with, we're going to look at infrastructure. So when I talk about infrastructure, it's quite a broad topic, but what I really want to focus on is how is code housed and deployed. At the moment, a lot of code is housed in containers, and the most popular framework for that is FastAPI. And this is quite efficient because FastAPI does a few things really well. It allows you to, first off, make different procedures or routes in your application very simply, and even generates external documentation that other agents can actually probably consume and know how to call your services. So there's a lot of pros for it. The issue comes in is how the containerization or serverless containerization, as a lot of people are pushing it, works under the hood. So this is take our example here. We've just imagine you're on AWS. You can probably think of any other cloud service, but for this example, just think we're on AWS. So we've got our FastAPI instance, which has our agentic, or not agentic, but just say our agents in it. So we're calling our AI components here. So we're getting internet traffic coming in, asking for a request, and then this is just spinning up a task to proceed and then sending the request back out. What you'll notice is the container can only take so much requests before it fills up. And what happens when it fills up is you have to make a new container to spin up to receive more requests coming in. And what a lot of people do currently is they use what they call Kubernetes. And the best way to think of Kubernetes is just imagine you've got pretty much buckets. And in those buckets, you've got different pods. So I'm not going to go into all the technical detail with here, but assuming in these buckets, you allocate different resources, and in these pods make up the bucket. So you could have multiple different FastAPIs in this pod here. And when this pod fills up, you can't instantiate any more of these containers. It means capacity is full. But what's nice is you can only have running at a time and spin up additional when more load comes in. But you do have to allocate it to this pod. A pod can have different resources in it. So you could have your FastAPI and you could have additional little server here. Say if it's not constantly being used, and you can still scale up and maintain your resources like that. All right. If this sounds very complicated, well, it is. And this is where my thoughts on a lot of the AI infrastructure at the moment, because many people are building this way. And a lot of enterprises have Kubernetes installed, so this makes a lot of sense to them. But what happens if you're not an enterprise, which 99% of businesses are? So if you're trying to do this approach and you've got AWS and you've got requests coming in and out, if you've got low traffic, this is not going to be a problem. You won't ever reach your capacity, so this might not affect you. But the other issue is maybe you do run an instance, but you're not even using this full capacity. So you're paying for extra compute you don't even need. And there is a solution for this. And this is what we call serverless. And a lot of people call it like lambdas. So you can think of it like a lambda function. Lambda functions. And essentially what a lambda function is, you write a piece of code. It could be functions that are housed in its own little code snippet or code container. You can even put it in containers itself. And what happens is it runs in the Lambda, and once it's done, the Lambda deletes itself. So after running, it'll pretty much just delete and not come back. So this is quite useful because now you have a request coming in and you're only using the resource for the Lambda run and then executing. The only issue is you pay for the time that the Lambda runs. So it's not completely free, but it's very cheap. And this is where things get kind of interesting with AI and infrastructure. Because in the old days, well, when I say the old days, the last 3 years before AI, Lambda functions are really appealing because an AI application, it's not an AI, sorry, an API call will take a few milliseconds. So this will execute, exit, and disappear. So it costs you nothing. But what we're seeing now is an AI response can take up to 22 seconds. And this is where it gets interesting. Because it can take up to 22 seconds, we are paying for the whole Lambda function call here, even though this Lambda might not even be running everything. It actually might do a request to a different server that actually has the model on it, which is doing the inference. So like this could be ChatGPT, for example. And we'll be charged the full 22 seconds of this, where compared to the containerized section, you're still paying a fixed fee regardless if it takes 22 seconds, 100 seconds, it doesn't really matter. But the industry is kind of evolving quite rapidly. So Cloudflare has just come out with what they call workers. And what makes workers so unique is you only pay for the CPU time that it actually executes. So if it takes 22 seconds, you'll only pay for pretty much the first bit and the last bit where you actually have to use some CPU to process the ins and outs of the data. So, when the request comes in, you'll do a bit of compute. You'll send the request to the model will come back, and then you'll send the result out. And that's quite an efficient way. All right, so we talked about the costs and the differences between the two, but what is the main difference between the containerization and the serverless that I'm talking about here? Well, one is they actually program differently. So the containerization part of it, you'll find a lot of applications are made with states. So you can hold your state in a global variable, and then applications or functions can access that state continuously, and that state doesn't always empty. With Lambdas, because it deletes itself after a run, it's actually stateless. So anything that is run or built in here is gone at the end. So you can think of these as self-contained. So you really have to design, especially for stateless, you have to design for stateless applications. You could put a stateless application in a stateful container, and it won't really be effective because it's just self-contained. It'll just essentially be a self-contained function. And this is where I find a very unique aspect to the AI race right now. Many companies aren't really building their own models, so they won't have to put it into an infrastructure and then host it that way and do inference. That's not really that common. What I do see happening is many companies do a call to a model like, ChatGPT, or if you're using AWS, you can use AWS Bedrock. So you could have your server, you could have your Lambdas, and then you could have AWS Bedrock here, which will have a Bedrock, so Bedrock. And essentially, you could have a minimal server to run maybe longer cron jobs and things like that. But for interbound actions, you could have a serverless state function where a request comes in, it will communicate with your Bedrock model and process the response back out. And why is this important? Because the other aspect I haven't really talked about is load. I talked about memory that's coming in, but we're not really talking about traffic. And stateless or serverless applications like Lambdas and Cloudflare workers work really great for this. Because each one is self-contained, you can spin up as many as you need that are coming in. And they can run in parallel. And you don't really have to allocate what is the full capacity that you need beforehand. It can scale up or down according to your needs. And this is very useful, especially for where traffic is a bit more chaotic. It's never linear. You always get spikes. So something might be calm and then suddenly just spike and then go down and, go calm again and then spike again. But so that's the infrastructure side of things. Hopefully it gives you a bit of idea what is the problems everyone is trying to solve. And my approach to this is I'm a big fan of serverless, so I've got a lot of bias here. I kind of come around to it there in the last year. But the problem is you do have to build for it. So I would always recommend you have your server You can make it whatever you want. You can have a FastAPI server, or it can be in any other language. You could have TypeScript, I don't know, even a Rust server if you've got the development capability for that. And then you could have your serverless applications to maybe serve more of your spontaneous internet traffic coming in, so you can upscale and downscale. And with that, you might actually reduce your costs, but it does come with complexity because you have to build like this. But if you know beforehand how you're going to allocate your resources and how you think about it, I think you'll get quite far. So the way I like to think of it is, for scheduled jobs, you always want good the server can be used for that, and that can be used for, we'll go into the next one a bit later, frameworks where you're ingesting information and you're processing and then you're retrieving it. So that's the quick high level of the infrastructure problem. Let's just jump into frameworks and my view on frameworks. So frameworks is a very interesting one. There's a lot of different frameworks out there, and they each do similar but different things. So let me talk about two that are very similar to each other but different to other things. So that's CrewAI and LangChain. And these frameworks are really great for getting a very unique agentic workflow going. What essentially they do is they have what they call a manager agent that handles the requests and talks to many other agents below it. And you can just think of these agents as just LLM calls. So each of them, their own LLMs, and the manager agent pretty much talks in between each of these and gets the responses back. But it is limited by the context size that it is passing through. So whatever context is being passed through from one to another, that's pretty much the limitation. The other issue with it is you can't really debug. Say you have one process and a jump between multiple different agents in a weird loop. It's very hard to debug or match that process again, because it's all a bit random because the way LLMs work. The second one that a lot of people love using right now is LangChain. It's probably one of the OG ones, and it has a huge developer community. So you pretty much get any function under the sun for AIs in LangChain, and it's probably one of the reasons why it's so popular. But one of my issues with LangChain, I feel it obstructs too much from the core layer. And when I'm talking about the core layer here is the API call to that layer at the end of the day. So what you'll find with frameworks, it's great to start with. It gets you your POC very quickly, so you can get your POC up and running, and people are, wow, that's amazing. Wow, that's a really great POC. And then you want to get to production. And this is where the issues start. So you want to get to production. And now your POC does really great for your traveling to drum station, your drum set. That's very great for your travel demonstration, booking your travel accommodation and such, or telling the weather, whichever POC you do. I'm just making things up here. But what you'll find is you need to now make sure when it runs in production, it's reliable. And it's not doing random things anymore. This is where you'll find a lot of problems with the framework start coming in, because you might have custom requirements. And well, AutoGen and CrewAI, I haven't looked at them for a few months, but they abstract too many layers from you. And you'll be hacking more at the framework to get the framework to do what you want it to do, rather than just building yourself. LangChain, you can kind of get there. You can use parts of it and customize the parts you really care about. But I've also had problems with LangChain just fighting more with the framework than I need to, and I've just found it easier to move away. So I would want you to think of this framework as a great way to get to a POC up and started, or a very specific use case if you can guarantee the results consistently. But otherwise, you should really look at understanding, how do I actually look at the core layer, my call to the LLM back, and how does the memory management work? And memory management is something we won't go into today, but just think about that's either the request coming in and restoring information either in cache or in memory, so you can process the results back and forth from an LLM in responses. So we'll tackle that a different day. All right, I want to go into the next section, RAG and vector databases. All right, this is still part of everything. I know there's a lot going on here, but I just want to give you a whole context of what's happening. Let's just go a bit down. This is too much. All right, let's go with what is RAG at the end of the day? So RAG, pretty much at the end of the day, what I want you to think of is a way for LLMs to get information from either from a database or from files or a bunch of different things. So actually, I'll go here. All right. So you can think of a RAG as we've got an LLM here. And say we've got a question. For example, what did I last week and what was the average sales? So this is a question that'll come in. A general LLM can't answer this. It doesn't have information to what you did or even your business, sales of the week. And this is where RAG comes in. So an LLM, you'll pretty much you'll build a bit of infrastructure around this. I'm really simplifying it down, but essentially you'll pass this query to, depending if you want to do an LLM first, but it'll probably be to your application. So you will have an import here, your query will come in, you'll process your query, and you'll try to retrieve something from your vector store. So you could have messing all of this up today, but essentially you'll have a vector database. This is trying to get to. And this vector, so, all right, let's try that again. All right, so you'll get a call, you'll have a question, you'll send that in response to wherever your endpoint is, and you'll try to route that question to retrieve the right information and then pass it back to an LLM to get back and respond. So you might have an LLM here to construct a query. So you'll say, hey, what did I do last week? And what's the average sales? So you pass it to an LLM. The LLM might break this query into its key parts, where in this case is last week's schedule. And it could then, the next step would be sales. And you might not find last week's schedule in the vector DB. You might find it from the relational database, and sales might actually be in the vector DB or in archives. And you'll grab this information, then pass it back to an LLM to generate a response and send that back to the user. That's a very basic understanding of what RAG is. There's a lot of different aspects to RAG, especially in terms of the vector DB graph databases and things like that. And then how do you process that data, retrieve it? I'm not going to get into that today. So let's RAG at a general high level. And why am I bringing up RAG with all of this? Now we're getting to agents, and you'll see where RAG becomes really important. So what is an agent at the end of the day? So an agent pretty much has a few things. It's an LLM, so it's pretty much just an LLM. It has some tools under it, and it's got memory. And what you can do is essentially, by allowing an LLM to have memory and tools, it can do various different processes. It can be self-deterministic, especially if you put it into a loop. So you can have what we call steps, essentially. So you can say, you can run or call tools 5 times, then I expect you to give me an answer. So you can think of it for yourself if you had to write into a paper and flip a page to thinking about an answer. LLM can do that, or using a calculator, that's a tool. And the tool part is where RAG becomes really important, because maybe you're asking a question and LLM doesn't have that information from the get-go. And it'll be really useful if the LLM could get that information before carrying on with a different tool's call that could be more beneficial for the answer. And this is where RAG is tying in. And all these parts is what's making AI very difficult for a lot of companies to scale quickly, is to think about all these different aspects. And I just see it's just a very interesting time. I think a few companies are doing it right from the get-go, but some are kind of patching what they previously did with new code. And I don't really want to go more into the agents and the agentic workflow right now, so I feel like I'll make this video too long. But I hope you found this deep dive and just my brain dump of how I see the AI industry right now, the different aspects from infrastructure to frameworks to RAG and to agents. It's been just me offloading a lot of my thoughts. I'll hopefully get a bit more better with the future videos. But I appreciate you watching, and I'll see you in the next one.